Hi, thanks for watching. Let's go over a few of these honors problems from week 8. I put a couple of hints on the top so that you would know that every time we were dealing with the complement of an angle, you could use 90 minus x, and every time that we were dealing with the supplement of an angle, you could use 180 minus x. So the first one said the supplement, so I'm going to go 180 minus x. And twice the complement, so I'm going to go twice 90 minus x. It says they differ by 35 degrees. So difference means subtraction. So it means if you subtract them, the answer is 35. I also saw some people take either the supplement or the complement, add it to 35 and equal it to the other one, and that would work too. All right, let's simplify this stuff on the left. So I'm going to drop down the 180 minus x, and then I'm going to distribute -2 to both of those terms. So I'm going to go minus 180, and then be careful here. It's minus x, so it's plus x. Oop, plus 2x. I almost made a mistake on that. Equals 35. And then this is kind of funny what happens here with the 180s. We have a 180 and a minus 180, so those just cancel out. And then I have a negative x that's like negative 1x plus 2x is just 1x equals 35. So the angle's 35 degrees. Let's check and make sure that that actually works though. So it says the supplement. So let's find the supplement of 35. It's 145. And then twice the complement. So let's find the complement is 55. So twice the complement is 110. So the supplement and twice the complement. Do those differ by 35? They do. So it looks like we got it right. All right, let's take a look at number 2. The supplement of an angle, so I'm going to use 180 minus x, is 12 more than twice its complement. So let's solve this equation. And then we have to, when we're done, we need to not only find x, but it says find the supplement of the complement. So 180 minus x equals 12 plus, and then let's distribute again, 180 minus 2x. So something funny happens again with the 180s. If I go minus 180 minus 180, they actually both cancel out. And then I want to get the x's all together. So I'm going to go plus 2x plus 2x. Negative 1x plus 2x is just 1x equals 12. So that's the angle. But then it says find the supplement of the complement of the angle. So let's find the supplement of 12. Oops, sorry. Find the complement. The supplement of the complement. Find the complement of 12. And then find the supplement of that. So 102 degrees is the supplement of the complement of 12. All right, the next one says the supplement of an angle, 180 minus x, is 60 less than twice the supplement of the complement of the angle. This is the trickiest one so far. The 60 less, I'm just going to tack on a minus 60 on the end, but we need twice the supplement of the complement. So the supplement of, not the angle, but the complement of the angle. So the supplement of 90 minus x. And then it's probably worth simplifying this part first before we move on and do the rest. So I'm going to drop down 180 minus x. And then 180 minus 90 is 90. And then minus x is plus x. So now I'm ready to distribute. 180 minus x equals 180. So I can tell that that funny 180 thing is going to happen again. Plus 2x minus 60. So let's go minus 180. So those drop out. And then let's go minus 2x. I know it's tempting to deal with the minus x instead, but I want the minus 60s on the right, so I want to bring my x's over to the left. So that gives me negative 3x equals negative 60. When I divide, I get that x is 20. But it doesn't just ask for x, it asks for the complement of 20. 90 minus 20 is 70 degrees. And then the last one of these, luckily, is the most straightforward of them all. So it says the ratio of an angle to its supplement is 3 to 7. So I like to deal with these just by calling one of the angles 3x and one of the angles 7x. And then I can just add them up and it equals 180 because they're supplementary. So 3x and 7x is 10x equals 180. So I divide and I get x is 10. So 10 isn't actually one of the, 18. 18 isn't actually one of the angle measures, but I can plug in 18 to find the angle measures. So 18 times 3 is 54 degrees, and 18 times 7 is 126 degrees. All right, the original angle, though, if you look at the order that it's written, it's a 3 to 7 ratio, the angle to its supplement. So the 3x one is the original angle. That's the 54. So it says find the ratio of the angle to its complement. So we have 54 degrees, and then let's find the complement of 54 degrees. 90 minus 54 is 36. So the ratio of the angle to its complement is 54 for the angle to 36 for its complement. We could leave it like that, but ratios are like fractions, so we can simplify them. Both of those numbers are divisible by 18. So we could just say it's a 3 to 2 ratio. All right, we got one more problem to go. This one is a tricky one because it's not only a system of equations, but it's got an x squared in there. It's a quadratic too. So there's a lot going on in this problem. So let me make sure first off that I label everything accurately in the picture. So we're given angle 1, angle 2, and angle 4. So first, how about I'll deal with my vertical angles? I can just set these two equal to each other. 3y plus 4x equals x squared plus 3y. And then this funny thing is going to happen again, where those are just going to go away, and we have 4x equals x squared. So I don't know how much you did with quadratics last year, but when you have an x squared, you actually want to get it equal to 0. So I'm going to subtract the 4x, and I know that those aren't like terms, but that's okay. I just keep them separate. And then you have to factor in order to solve this. So I noticed that they have an x in common. Factoring is like doing the distributive property backwards. So what would I have to distribute the x by to get x squared minus 4x? Well, I know that x times x is x squared. And then I know that x times 4 is 4x. Then we're going to use the zero product property. We're going to take each piece and set it equal to 0. So x is 0. That's one of the solutions. Or x minus 4 is 0. So the other solution is 4. When you're dealing with a quadratic with x squared, there's usually 2 solutions. So I can actually go ahead and plug that back into the problem, and then that's going to make my life a little bit easier when I'm trying to solve for x. So I'm going to plug that back in to angle 4. So I have angle 1 and angle 4 are going to add up to 180 degrees. So first off, let's try plugging in 4. When I plug in 4, angle 4 is 3y plus 4 times 4. So 3y plus 16. So then I can add up 3y plus 16 plus 20y plus 3 to get 180. So I'm going to combine like terms, 23y plus 19. 180 minus 19 is 161. Is that divisible by 23? Oh, it is. It's 7. All right. We want to pair those up. So it's like when x is 4, y is 7. So when x is 4, y is 7. All right, let me change colors. What happens when x is 0? I need to plug that in Also, when x is 0, this one's just 3y, and we just get 3y plus 20y plus 3 equals 180. So this time we get 23y plus 3 equals 180. Is 177 divisible by 23? Nope, we didn't get quite so lucky. So we could make it a decimal. I'm actually going to say let's keep it exact and do a fraction though. So when x is 0, y is 177 23rd. So those are our solutions for the system of equations, but then let's see what it asks us to find. It says find both possible measures for angle 1. So I guess we really just care about the y values. So for angle 1, I can plug in 7 for y. 20 times 7 plus 3 is, I think that's 143, but I'm going to use my calculator to check. Yep, 143 degrees. So that's one possible measure. Or the other possible measure is I'm going to plug in 177 23rds. 20 times 177 23rds plus 3. I could keep it exact and keep it as a fraction, or at this point, since it's the end of the problem, it's probably okay for me to round. So I'm going to call it 156.91 degrees. So that was a tricky one. We are going to continue to do more systems of equations and more quadratics in this class throughout the year. Having them both combined in one problem is really a challenge. But hopefully that makes a little bit more sense. And let me know if you have any questions. Bye.